Section 2.2, multiplying monomials. So the goal here is to model the product of a monomial and a polynomial using the distributive property. This is going to be two parts. The first part is multiplying monomials, and then we're going to deal with the polynomial part. So let's recall for a moment here that the monomial is what? Well, it is a one-term, like a one-term polynomial. Okay, and remember, a term has two parts. It has a coefficient and it has a variable part. So that's what my term consists of. So what about multiplying monomials? Well, the product of two factors is found by multiplying them together. So the following procedure may help you. So step one, determine the product of the signs. Okay. Step two, determine the product of the numerals or numbers. So these would be the coefficients. And step three, find the product of the variables or letters. Okay. So an example here, negative 2x times 3x squared. So step one, determine the product of the signs. So if I have a negative times a positive term here, I'm going to have a negative term. Okay. Step two, determine the product of the numerals or numbers. So 2 is my coefficient for x. 3 is the coefficient for this term here. So 2 times 3 is 6. And then step 3, find the product of the variables or letters. So again, x times x squared. So if you have two powers with the same base, you have to add their exponents. And remember, there is an invisible 1 here for x. So when you add the 1 with the 2, the product rule says add those exponents, 1 plus 2, I get 3. Okay, and each of those steps is individually broken down here. So the signs, the coefficients, and the variables. Okay, so that's the idea behind multiplying monomials. So if we take this idea and we went one step further, we take this idea and apply it to some examples. Let's try and answer them. So example 1, simplify 5x times 3x squared. Notice how both terms are positive. So my final result will be positive. Okay. So I'm going to write here an equal sign. If I know it's a positive value, I can move on to step 2. Multiply the coefficients. So 5 times 3 is 15. So 15. And then multiply the variable. So x times x squared. Remember, there is a variable exponent here of 1. So when I multiply two powers of the same base, I add their exponents. So 1 plus 2 is 3. So x to the exponent 3. Okay, part B. So negative 2y cubed times 5y squared. So first of all, signs. I have a negative term here and I have a positive term. So my end result is going to be a negative. Multiply the coefficients. So 2 times 5 is 10. Okay, you can combine step 1 and 2 by multiplying the coefficients themselves, including their signs. So you could say negative 2 times positive 5 is negative 10. And then multiply the variables. So y cubed times y squared is going to be, two powers with the same base. You rewrite the base, so it's y, and if you're multiplying the powers, you add their exponents. So 3 plus 2 is 5. So y to the exponent 5. Part C, 10x squared times 3y. So here I multiply the 10 and 3 together. I get 30. So 10 times 3 is 30. And these two powers have different bases, so I have no choice but to write them separately. So I cannot combine them. X squared times y. And I'll put the variable part with the higher exponent first. Part D. Let's move up here. Part D. 8x squared times y times negative 3xy. So 8 times negative 3 is negative 24. Multiply the x squared with the other x here. So this x is an invisible exponent of 1. So 1 plus 2, product rule says I have here x to the exponent 3. Multiply the y times y, I get y squared. Again, invisible exponents of 1 each. So I add those exponents together and I get 2. Okay, let's look at something even more complex, more variables, more exponents. So here I have a negative 4 for my coefficient, and I have a negative 3. So two negatives will make a positive when I multiply them. So negative 4 times negative 3 is positive 12. Then I have the a's, so a to the exponent 1 times a to the exponent 5. I add their exponents. 5 plus 1 make 6. So a to the exponent 6. Then I have b squared, and then b, so b has an invisible exponent of 1, so b times b squared, add the exponents, 2 plus 1, which make 3. So b to the exponent 3. Then I have c to the exponent 3 and c to the exponent 3. Add those exponents together, I have 3 plus 3, which is 6. And there you go. Part F. What about I, j, and k as variables? Okay, so 4 times the coefficient here, which is just a negative 1. There's an invisible 1 because it's just a 1. So 4 times negative 1 is negative 4. What about my I? So I have an I to the power of 3 plus I to the power of 1. So you add their exponents. So multiplied by I to the power of 1. So you add their exponents. You have j to the exponent 1 times j to the exponent 3. So I add those exponents, 1 plus 3. And then I have k to the exponent 2 times k to the exponent 4. So I write them as a single base k, and I add their exponents 2 plus 4. When I simplify, I get negative 4 times I to the power of 4 times j to the power of 4 times k to the power of 6. And remember, like the last lesson, whenever you have your negative exponents, convert them to a positive exponent. Here's a challenging one. What do I do with this? Well, let's combine these two first. Okay, so so I mean, it doesn't matter which one you combine first because they're all these brackets are being multiplied with each other. Okay, so I'm going to combine these two first. So coefficients, the numbers. So 5 times negative 2 is negative 10. So I'm going to keep this in brackets still. So negative 10. Then I have x times x cubed. So the invisible exponent of 1 here, I'll add to the 3. It becomes x to the exponent 4. Then I have y squared times y, invisible exponent of 1. So I add that with the 2 here. So that becomes y to the exponent 3. Z to the exponent 4 times z to the exponent 2 becomes z to the exponent 6. Close the bracket, and let's deal with the next one. Now, notice how this is a bracket with an exponent 2 outside. So I can rewrite this as negative 3 x to the exponent 4, y to the exponent 3, z, close the bracket, and then multiply it by itself again. Negative 3 x to the exponent 4, y to the exponent 3, and z. Okay. Now when I multiply these two factors, I can multiply their coefficients. Negative 3 times negative 3. Two negatives make a positive. So here I'm going to write down positive 9, put it in brackets. X to the exponent 4 times x to the exponent 4, add their exponents from multiplying with two powers, add their exponents. So 4 plus 4 is 8. So x to the exponent 8. Multiplying two powers again, y cubed times y cubed, add their exponents. 3 plus 3 is 6. And then z times z, each has an invisible exponent of 1. I add them together and I get z to the exponent 2, z squared. Okay? Now on my next step, this is a multi-step problem. I can combine now these two terms. They're being multiplied. So again, as usual, I just multiply the coefficients. Negative 10 times 9. A negative times a positive is a negative, so I have negative 90. X to the power of 4 times x to the power of 8, add their exponents, x to the power of 12. Y cubed times y to the exponent 6, add their exponents, y to the exponent 9. And then z to the exponent 6 times z to the exponent 2, I add their exponents, 6 plus 2, I get z to the exponent 8. And then there's my final answer. And that ends section 2.2, multiplying monomials.